So we start by looking at concepts of chemistry, what matter is and its transformations. We know that there are certain classifications of matter. We also know that we're going to make measurements on matter. We're going to use instruments, and because those instruments have certain precision associated with them, we have to be mindful of significant figures. The next topic is the next natural extension to that idea. Sometimes we make a measurement, but we want to translate that measurement into something else that's important for us. And the concept, the idea behind that is known as dimensional analysis, okay? We're going to take our measurements and we're going to transform them into more useful information. We use conversion factors throughout the entirety of this semester and next semester as like our main tool to attack chemical problems. And we can do a lot with just sort of understanding the basic algebra associated with dimensional analysis, okay? We're changing things, okay? We're changing them to a different sort of unit while keeping them the same. It's really algebra where we keep multiplying by 1. This is a point I'm going to make over and over again this semester. Conversion factors come from equalities. So the way that I'm going to introduce it to start with is, here's an equality. We have 4x equal to 3y. In our problems, in our chemically relevant problems, okay, x and y are going to be units. We already mentioned that units are treated like variables. So if I have 4x and I have 3y, I have this equality. I can take this equality and I can build conversion factors. Conversion factors are fractions. So how do I take this equality and build a conversion factor? If I take this whole entire thing and I divide both sides by 4x, okay? On this side of the equation, 4x divided by 4x, that is equal to 1. And on this side of the equation, I now have a fraction. And this fraction will allow me to take x information and turn it into y information. Again, the point I'm making above is it really is multiplying by 1, but we're changing how we look at things. We're no longer going to look at things in terms of x. We're going to look at things in terms of y, okay? We could also take that expression and instead of dividing by 4x, all right, we could divide by the 3y. And so what we could be left with on this side is 4x divided by 3y is equal to 1. So if we just reverse that algebra. And so again, you'll hear me say, conversion factors are multiplying by 1. They come from equalities, and there's really 2 different conversion factors you can build from any equality, all right? So now we can ask ourselves questions like how many x's are there in 6y, all right? So what we want to do is we want to use a general tactic for this sort of problem. And what we want to think about is the information that we're starting with and the information that we're trying to go to. So let's write this again as an equality and kind of go through the thought process here, okay? For this sort of problem, what we have is given information. And this given information is like a measurement. It's often a measurement. It could be something that's kind of just given to us as a definition. But in this case, let's treat this like a measurement. This information is something that we got from an instrument, but we want to turn it into something more useful. We want to turn it into x information. So how do I take a y and turn it to an x? Well, I have this equality. And I know that this equality can build fractions, okay? We can build a fraction where we're kind of multiplying by 1, but it's changing our information. So what I can do is next to this, I can say, okay, I'm going to use dimensional analysis. I'm going to use a conversion factor. Here's the equality. The 3 is stuck to the y. I have a y here. If I put the y in the denominator, and if I put the x in the numerator, then what will happen here is when something's in the numerator and something in the denominator that are the same, they cancel. And so I take my y information and I turn it into x information, okay? So I can plug this into, all right, my calculator. 4 times 6 divided by 3, this looks like we're going to get 8x out, okay? So I took 6y and I turned it into 8x. All right, 6y is 8x. So again, we haven't really changed the measurement. We've just changed how we look at the measurement. We've changed its dimension. We've changed, all right, its unit. Okay, so it's about doing a unit analysis. Okay. So conversion factors come from two different sources. And you can see this on slide 2 of PowerPoint number 1. All right, you'll see a list of different equalities, right? Sometimes these equalities come from measurements. So conversion factors, which come from equalities, can come from measurements, and then they are subject to significant figures, right? Sometimes equalities come from definitions, though. All right. Now, if something is defined, okay, even though it looks like a conversion factor and all that, if something is defined, did I need to use a measurement to actually kind of think about where it came from? No. Did I need to use an instrument to quantify it? No. So if something is just defined, all right, definitions are what we call exact numbers. And exact numbers, because there's no ambiguity about what they are, because there's no instrument that we need to use to get them, these are not subject to significant figures. And you'll kind of know these because, like I said, you can use the word exactly to describe them. And as soon as you can say that word exactly and you don't need to use an instrument, they're not subject to the significant figure rules that we talked about in the last video, okay? So what are some examples of some measurements versus some definitions? Well, an important definition to know that we use over and over again is 2.54 centimeters is 1 inch. Now, from this bit of information, we should be able to look at this and say, okay, I can build two different conversion factors. I can say 2.54 centimeters is 1 inch, and I could take inch information and make it centimeter information, or I could do 1 inch is 2.54 centimeters. So just like our last example, whenever we have an equality, we have to be able to look at that equality and build the two different conversion factors from it. This would take inches and make it centimeters, and this would take centimeters and make it inch. This is a 1 here, just so you can kind of see. Okay. There are some of these dimensional analysis type problems, some of these conversion factors that are coming from measurements. So let me just look one up here. 1 kilometer is 0.6214 miles. This is not a definition, right? This is something somebody would have to measure. This I'm giving you as a definition is something that's exact. So whenever I use this in a problem, this 2.54, it's like it has infinite precision. We're never going to be limited to significant figures here, okay? There's not really 3 significant figures here, okay? It really is that 2.54 centimeters is 1 inch, and that is a set and true definition, okay? On the other hand, up here, this is a measured conversion factor. 1 kilometer is 0.6214 miles. This is something that's given to you as measured. Now, we should be able to build two conversion factors from here. We should be able to see 0.6214 miles is 1 kilometer, is a fraction that we could build, or we could build the opposite with the 1 kilometer on top, okay? But whenever I use this in an analysis, all right, if it came from a measurement, okay, then I know I'm limited to 1, 2, 3, 4 different significant figures here. I know I'm limited to that decimal place depending on the work that we're doing. Now, conversion factors are often associated with multiplication. So that's why we kind of look at this and say, okay, yeah, when I use this in a calculation, I have to be mindful that there's 4 total significant figures here, whether I use this version or the flipped version, okay? So when you look at this slide 2 PowerPoint, okay, don't think of it as something that you have to memorize, okay? Some of these we'll use often enough that you will memorize them, like 2.54 centimeters is 1 inch. but just kind of look at them and say, okay, yeah, in that list on here, right, some of these don't have anything written next to them about being definitions or being exact. Those come from measurements, but each equality I can build two conversion factors from. But there are some that say, hey, this is a definition, this is something that's exact. I can still build two conversion factors from them, but these conversion factors would not be subject to our significant figure rules, right? To kind of get some idea of conversion factors and the practice, and again, it's something you're probably familiar with, but still, it's good for us to take some time to do some examples, all right? Let's look at the flag example from your slideshow. So this is in PowerPoint 1. And I believe it's slide 6. All right, but let me check one more time real quick. Sorry, it's slide 4. So in PowerPoint 1, slide 4, you're going to see an example that's given to you about flags, okay? And what it says is, hey, you have this parade that's going on, right? And in that parade, right, you have these flag stands, right, that are set up to line the parade. And each stand has two flags, two American flags on it. And there's 100 stands, right, on your parade, okay? And what the question asks you is, how many stars are there along the parade route? Now, when I like to sort of approach these problems, especially in the beginning, I like to make a list of information that's given. So as you're reading this problem, you can start to kind of build your conversion factors from a list of information contained in the problem. So for example, we start off by saying, hey, all right, each stand that you have along the parade route can hold two flags. Okay, that is an equality. One stand holds two flags, so one stand is equal to two flags. Any equality I have, I can build, right, conversion factors from. We also know that there are 100 stands on our parade, all right, in our one parade, okay? So based off of this information then, what we're asked to do is we're saying to look at our one parade, and I'm going to write the information that we're asked to analyze on the left-hand side. And what we're supposed to do is supposed to turn this into some other bit of information. We're supposed to take our one parade and turn it into a number of stars. Now you guys can probably figure this out on your own without having to do this conversion factor technique, but we're going to establish this idea where we make a list, we look at what we're trying to analyze on the left-hand side, where we're trying to go, and we write it on the right-hand side, and make a connection with conversion factors. We're going to set this up with a problem that we understand so that when we do more difficult problems, we have this general technique down. List, starting point, ending point, connection with conversion factors. If I look here, I see information about my parade shows up just in one spot. So in this instance, what I'm going to do, let me switch colors here, is I'm going to say, okay, here's my parade, here's parade information. I'm going to build a conversion factor. And I'm going to say, okay, is parade my final result? Well, no, so I have to get rid of parade. So I'm going to put one parade down here. Parade information is attached to stand information, okay? So one parade is 100 stands, right? One parade is 100 stands, okay? Now I look and say, okay, I have stand information. Is that star information yet? Well, no, not really. So guess what we're going to have to do? Use more conversion factors. I do see how stands relate to flags, though. So I can build another conversion factor here using the same ideas, where I put one stand down here, and that stand can hold two flags. So I kind of used my information that's given in the problem at this point, right? But am I at my final goal yet? Well, no. I can see that parade is gone, right? Because they cancel, because one's in the numerator, one's in the denominator. I can see that stands is gone, because one's in the numerator, one's in the denominator. But I have flag information and I need star information. Okay? So like I said, pretend this is a USA flag that we're talking about here. Do you know of a relationship between a USA flag and how many stars there are? Well, sure. For one flag, there are 50 stars. So the reason I point out this example here is, was it information that was given at the start? Well, no. But there are bits of information that we will know, that we will memorize, that we'll have to just have in our back pocket as well to be able to use in conversion factor problems. Okay? So if you look at this now, all right, flag cancels with flag. We have our final unit that matches the unit we were trying to get to. So now I can put this into my calculator. I can take 100, I can take 2, and I can take 50, and I can multiply them all together. You could multiply by 1 and divide by 1, but remember that doesn't really change your outcome. So to save time, just kind of focusing on the numbers that matter. 100 times 2 times 50 gives me 10,000. Okay? 10,000 stars would be along that parade route. Okay? We haven't changed the parade. We're just looking at a different part of that parade. We multiply by 1, multiply by 1, multiply by 1, but we got different information. Now, we did math. So if we did math, what do we check? Significant figures. So now we go through this analysis part. Is it really 10,000? Or is it really 1 times 10 to the 1, 2, 3, 4th? Do you know what I mean? Is it something that we have to represent in terms of measurements? Hold on a second. Was there exactly one parade? Yeah. So if I use that word exactly, that value didn't come from a measurement. So is that subject to significant figures? No. I didn't need like a paradeometer or something weird to actually kind of look at that and see that there was one parade. Can I say that their one parade had exactly 100 stands on it? Well, yeah. I could go and count those stands. Do I need an instrument to count? Well, no. This counted number is also exact. So does this affect our significant figures? Not at all. One stand has exactly 2 flags on it. So do significant figures matter there? No. And finally, can I count those 50 stars and say that one flag has exactly 50 stars on it? Yeah, I can. So is that subject to significant figures? No. So all of these numbers are exact. So this number right down here, it's also exact. So this is an exact number, and I'm going to write the word exactly next to it because it's not coming from instruments. It's not coming from measurements. There's no ambiguity. This is exactly how many stars you would see. Now, this is a very rare case for problems that we'll do. Usually at least one of our things will be a measurement, but it drives the point home. Whenever you're looking at conversion factors, you ask yourself, okay, if I look at these conversion factors and they're exact, and I can say that word exactly, and it doesn't come from a measurement, does it affect your significant figures? And the answer is no. Okay. So let's use that slide 2 information and do one last example. And again, it's really no different than the flag example, except some things here are coming from measurements, but it's the same idea. We kind of take one bit of information and try to get to a more useful bit of information. So how many quarts, which I'm going to label QT, how many quarts are in 3.2 ounces? All right, how many quarts are in 3.2 ounces? So a lot of the times we kind of get stuck on where we start and where we're trying to go. This is a little bit easier. Can everybody see we're given our starting point? We're given the thing we're trying to analyze. We are trying to analyze a measurement, 3.2 ounces. Now, how do I know that this came from an instrument? How do I know it's a measurement? Because I know that ounces are volume. And if I'm going to figure out that something has 3.2 ounces, I had to put it in something like a graduated cylinder. So this isn't anything that's defined. It's something that comes from a measuring device. This will affect the significant figures of our outcome, right? So I figure out what I'm trying to analyze, and I figure out where I'm trying to go. How many? Okay, I'm asked a question about quarts. So I'm given ounces, and I'm trying to get 2 quarts. So what I'm going to do is I'm going to link conversion factors between these 2 objects. So if you look at that slide that I keep referencing, okay, slide 2 with the conversion factors on it, right? Is there a direct link between ounces and quarts? So take a second to look at that. Even pause the video if you have to. What you'll see is that there's no direct link between ounces and quarts. You have a lot of information that's there, right? So what are we going to do in this situation? You look for an intermediary, all right? I do see information that relates ounces to centimeters cubed. And I do see information that relates centimeters cubed to quarts. So here's the thought process. Find a way to build conversion factors that takes the information that you're given, that takes you from the information that you're given to the place that you're trying to go. So I look there and I see 1 ounce is 29.57 centimeters cubed, right? 29.57 centimeters cubed. I find that conversion factor, it's an equality, but I know how to write those equalities as conversion factors. Ounces and ounces are going to cancel and I'll be left with centimeters cubed. That'll be helpful because I also see that we have 946.4 centimeters cubed is equal to 1 quart. And that's also on that same slide. So centimeters cubed goes away using our conversion factors idea, and what we're left with is quarts. I plug this in my calculator and I get 0.0999,830, and some more digits come out, quarts. And then I ask myself, okay, is this my answer? Or how am I going to accurately report this answer? I did math, I have to consider significant figures. Did this come from a measurement? Yes, it did. And there's 2 total significant figures. Why did the total significant figures matter? What math are we doing? Multiplication. There's 2 significant figures here, all right? There's 4 here. There's 4 here. If these came from measurements, all right? So then what we're left with is, okay, 2 significant figures, 4 significant figures, 4 significant figures. My answer has 2 significant figures in it, all right? Here's a situation where we would round up, okay? So, my answer has to have 2 significant figures, but really all these would bounce up. Okay, the only way to represent this correctly based off of rounding is to write it as 0.10 quarts. Everything will kind of bounce up, all right? You show the correct number of significant figures. Another way of showing this would be to write it as 1.0 times 10 to the minus 1 quarts. This would be writing it in scientific notation. I just show this as an example. Remember, these 2 things are equal. If I move the decimal point in this way, in this direction to the right, remember in terms of scientific notation, we introduce a negative exponent in terms of a 10, because really the 10's in the denominator to get something that's less than 1. 1.0 times 10 to the minus 1 quart is the same as 0.1 quart. Again, rounding rules, because this was higher than 5, I bumped everything up. Really, I bumped this up, but then it would bump this up, but then it would bump this up. So it's an interesting case, and I just wanted to show you that, yep, what you focus in on are your significant figure rules. It doesn't matter that once you rounded, you now put a number here. What matters is there will be 2 total significant figures in your result. So this is the general idea behind conversion factors. And as I mentioned it before, we're going to use these again and again in different contexts. So it's one of these just, again, foundational tools to get comfortable with as soon as you can. All right. In our next video, we're going to apply this to more of these types of situations, focusing on chemically relevant conversions that we'll have to kind of get down before we go on to more complicated scenarios.